Starting off with our linear model, our data is kind of an S shape, and so if we're going to try and fit a line to it, one line isn't going to be enough. What we're going to have to do is do one line for this starting section, one line for the bit where it's increasing quite rapidly, and then one line for where it's kind of tailing off a bit at the end. So if we start off with our first line and we get it to cover this initial section at the beginning, then we've got this line doing what is kind of the introduction of your outbreak. We've then got this section here where we're looking at realistically a much faster rate of increase, so more people dying. Tends to be easier to try and line it up in a straight line from you. And we're looking for what is effectively a line of best fit going through this next section. And then lastly, our third line is going to have to cover this bit at the top. So, looking at this, we've got our first line. So our first line is this section here, starting at 0 and going up to this point here, which is where it crosses over. So our first line is going to have a range that is from 0 less than or equal to x less than or equal to scales going up in 1, so in this case it's going to be up to 18. This does mean that this second section is going to start at 18, and so we've got less than or equal to 18 is x is less than or equal to, and this one is going up to this point here, so that is at 60. So our second line is going to cover from 18 up to 60. And then lastly, our final line is going to start at 60 and then go up. So we've got our 3 sets of lines. So we're going to have to calculate these points. So we'll want to choose a point on the line. Now, looking at this one, we can choose this first point here because that is on our line. And that point is going to be able to be found from our data. So our first point that we're using, so for line 1, we've got our first point that is at 0 and 53, and our second point, if we use the actual third point, would come in at 14,199. So because this is a line, it's going to fall into y equals mx plus c. So this first point tells us that our intercept is at 53. So we're only going to have to work out the gradient. So for your gradient, we have m equals y2 take y1 over x2 take x1. So our value of m is going to be 114 take 53 take 0. So m is going to be equal to, right, that's a fraction, so 119 take 53 over 14 take 0, 33 over 7, and 33 over 7, we can either put in as a fraction or as a decimal. A decimal is probably going to be easier in the long run. So what we can then substitute into our equation will be y equals 33 over 7 x plus 53, and so that is for line 1, and line 1 is a range between 0 less than or equal to x less than or equal to 18. Then going on to our second line. Our second line is going to be between 18 and 60. And we're going to need to take 2 points in exactly the same way. So looking at this, we can use this point here. So that first point that we actually passed through is at 21, and that's 21,182. And then if we look up at the other end, we've got it passing through this point here, and that point there is going to be 780 and 60. So we've got 2 points nice and far apart, so we get a better version of accuracy. So we've got our 2 points, and again we're going to need to use y equals mx plus c. So y equals mx plus c. So m is going to equal y2 take y1 over x2 take x1. Now when it comes to actually doing this on your Word document, you can do it in equation editor. You need to do it in equation editor, but writing out this is not going to be that difficult because you've got it up here and you can just copy and paste. So y2 here is 780 take 182, and that is going to be over 60 minus 21. So it's going to be a fraction. We've got 780 take 182, and that's over 60 take 21. So that's 46 over 3. Okay, now this one's a little bit different because we don't have a value of c, so we're going to have to substitute in. So first off, we know that our equation is y equals m, which was 46 over 3, x plus c. So if we substitute in one of these 2 points, so if we use this first one, we've got y is 182, and that is 46 over 3, and your value of x, which is 21, plus c. So c is going to be equal to 182, take away 46 over 3, lots of 21. So that's coming in at minus 140. If you look at your diagram, it makes sense that your intercept is at minus 140, because if you carried on extending this line, it would go across below 0. So once we have got c, we can substitute that back into our initial equation. So we've got 46x over 3 minus 140. And the range for that one, it was true between 18 less than or equal to x less than or equal to 60. Our third line, so line 3, that's the one that's true just for this section up here, so it's only true at above 60. So looking at this, we can choose our last point here that it goes through, and that is going to be 91,812. And this first point is actually the same as the last point on the other one. So the last point on line 2 was 60,780. And that goes up to our last point at 91,812. So, still a straight line, done almost identically as the way you did for the second line. What we've got, it's y equals mx plus c. M is y2 take y1 over x2 take x1. So m is equal to 812 take 780, 91 take 60, which gives us a value of m. So 812 minus 780, 91 minus 60 is 32 over 31. So 32 over 31. So we've got 32 over 31, and then we can substitute in one of our points. So y equals 32 over 31 x plus c. Then if we substitute in one of our points and we choose the second one, then we've got 812, which is equal to 32 over 31, and our x value at that point was 91, plus c, which means c is going to be 812 take away 32 over 31 so we end up with something massive, which isn't actually very helpful in that form. So what we can do is turn it into a decimal, and as a decimal that is going to be 718. So what we've got is y equals 32 over 31 x plus 718, and that is true when x is greater than or equal to 60. So this, along with the graph it came from, needs to go into Appendix A, and the stuff that's just been handwritten needs to be written up neatly using Equation Editor in the different sections on your actual Word document.